data structure series, I am going to talk about another question of time complexity. So let's write the question. It's let me write it like integer sum, say 0, and for integer I is equals to 1, I is less than or equals to n, and I plus plus, okay, it's not I plus plus, it's I multiplication equal to, and its sum plus equals to I. Alright, so before starting this lecture, make sure we understand what is this symbol means. This symbol means is I is being multiplied by 2 each time the loop executes. It's like I, so if I write like the steps, the I and the pattern, oops, let's start it like, what's it called, like, yeah, so it's like this. So at my first step, when I is equals to 1, when I is equals to 1, what does it happen? The sum execute, and when my loop executed completely, sorry, not completely, when my loop executed only one time, the I incremented from 1 to 2. It's because I is being multiplied by 2, and in the next step I will be multiplied again by 2, which is 4, and therefore again 4 will be multiplied by 2, which is 8, and therefore it will be like incremented in this series. Okay, so let's get started. So when my I is equals to 1, the sum condition executed. When my I becomes 2, which is 1 is being multiplied by 2, sum execute another time. When my I is again incremented or multiplied by 2, it becomes 4, and therefore it becomes 8, 16, and so on. So at my first step, the second step, third step, fourth and fifth step, let's assume the number of steps is p, and my I becomes n. So I want to establish a relation between p and n, which is like at pth step, what is my n? What is my n, right? So I want to find out this relation. So what is this relation? This relation is simple pattern. If you notice carefully, like it's like 1, 2, 4, 8, 16. I hope you already realize like it's 2 to the power 0, 2 to the power 1, 2 to the power 2, right? If I'm not mistaken, it's actually 2's power, which is 2 to the power 0, 1, 2, 3, 4, and so on, right? So what will be 2 to the power here? What will be 2 to the power in here? right? If you notice carefully, this 4 is like a relation. This 0 is a relation of the steps number. Why not the I? It's not I. If you see carefully, 0 and 1, initially you can choose like 1 and 1. Initially you can choose like anyone between them, but when the series continue, like at this line, 8 and 3, 4 and 3, 8 is not near as in 3, but 4 is near in 3. Like 4 is also not near as 2, like 3 is near at 2. So if you see that 0, 1, 2, 3, 4, it actually follows the steps number, but minus 1, it follows a pattern which is 0. It could be written as step 1 minus 1, right? It could be written as 1, sorry, step number 2 minus 1. It can be written as 3 minus 1, 4 minus 1, and so on. But what about this? It could be written as you can see, p minus 1, right? So I wanted to write a generic relation which is p minus 1, and that is the relation of n and p. Oops. And that is the relation of n and p. So if we write in here, you can see that n is equals to 2 to the power p minus 1, right? In here, the base, this is the base 2, so we can write 2 base log n, which is p minus 1, just basic algebra. And we want to find the value of p actually. Why p, not n? You will see it later. P is equals to 2 base log plus 1, right? So this is my p. So why was I writing, why was I trying to find the value of p? What is the purpose? Well, it's very simple. So can you please tell me how many times this for loop will be executed? This for loop will be executed the number of steps. The number of steps. What is the number of steps? The number of steps is p. We are assuming that this loop is being called by p times, and n is just a relation. It is not like running n times, because I is actually being executed, sorry, I is actually being multiplied by 2 each time. Therefore I will actually reach to n, but the number of times the loop will execute is not n, it will be p. This is the reason why we are trying to find the value of p, not n. And you already know that this is order of 1 time and this is order of p times, right? Because it is running p times. This is order of p times as well. P minus 1 or p, anyway, not going to complicate it much. It's like order of p. So it actually if I define it specifically, it actually runs p plus 1 times, because as I told you before, even though it is not like very significant in time complexity, but you must know it that this loop will execute p time and again check for 1 time, and which is the false condition, right? 1 is for false condition and p is like p times true condition, and therefore the sum will be executed p times. So as you can see, the total time of this code is order of 1, If I write it like this, it's like 1 times plus it executed p plus 1 times and it executed p times. So what was my value of p? My value of p was 2 base log n plus 1. So we could write it like, so we could write it like 2 plus 2p, and it is 2 plus 2 and 2 base log n plus 1, right? So if we multiply it by 2, it can be written as plus 2, and it becomes 4 plus 2 base log 2 into 2 base log n, which is order of 2 base log n. So this is my answer. There's a small notation in here. In computer science, when we write log n, it is by default becomes 2 base log n. You need to only write the base number when the base is anything but 2. It's like if you find it like 3 base log n, you cannot write it like log n. It will be false, because by default in computer science we assume that only log n is 2 base log n, right? Not 3 base log n. So in this question, my base of this log is 2, but when you may encounter unknown log base, you have to write it specifically. So you cannot just write log n. If you write log n in this case only, where the base of log is 2, it's okay, you will get full marks. However, it actually depends on faculty. If they like really instructed you to write the base, you cannot help it. But in computer science, when we write log n, we understand that it is by default 2 base log n. Okay, so thank you for staying with me. This is the end of this video. I hope you like it. Thank you.